ઝૂમ યુટ્યુબ લાઈવ જે છે જે એકાઉન્ટનું તમારે કરવું હોય એના ક્રેડેન્શિયલ તમને યુઝડી પાસવર્ડ હોય તો થઈ જાય. હમણાંની લિંક આવે એટલે તમે મોકલો બરોબર. એમસીએ સ્ટાફમાં મેલ કરી દો એટલે અમે લઈ લેજો. તો ઝૂમમાં તું જોઈન નહીં થતો ચાલશે ને? હા ચાલશે. સ્ક્રીનશોટ લઈ લેવા જોઈન થઈ જાય. હા વાંધો નહીં ચાલશે. ઝૂમની ગઈકાલે કરી હતી ઈ જ છે. હમ ન મળે તો કે મને અલગથી આપો પછી. ન મળે તો મને કે ગઈકાલે મેઘના મેડમને મેલ કર્યો હતો ને તો ગઈકાલે તો જોઈન થઈ હતી કે નહીં ઝૂમમાં. હા બસ ઈ જ તે લિંક છે. તમે જે નંબર Hello, good morning.
Good morning, sir.
We with prayer. Start prayer.
Okay.
या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा।
Okay. So, good morning, one and all. Actually, we are moving towards machine learning. भी बेसिक लाइब्रेरीज है जिसका ये STTP है, शॉर्ट टर्म ट्रेनिंग प्रोग्राम। तो पाइथन बेसिक्स हमने कंप्लीट कर लिया, क्रैश कोर्स। देन वी हैव स्टार्टेड विथ नमपाई एंड पांडा। अभी कोई भी मशीन लर्निंग प्रैक्टिकल इंप्लीमेंट करना है तो उसके लिए जो भी आपके पास फील्ड है, जो भी फीचर्स है, उसको किस तरह से आप और फाइन ट्यून करेंगे, उसको क्लीन करेंगे, ताकि आप उसको ML प्रैक्टिकल के अंदर उसको दे सके और आपका मॉडल अच्छे से काम कर सके, अच्छा रिजल्ट दे सके। सो cover in today's session. I would like to invite Ria ma'am to introduce our today's speaker. Invite our today's speaker, Ria ma'am.
Thank you, sir. Good morning, everyone, and welcome to third day of our short-term training program on essential Python libraries for machine learning, data visualization, and data analysis. Today, we are once again delighted to have with us Dr. Meghna ma'am, a highly accomplished academician and researcher who engaged us with insightful sessions yesterday. Let us warmly welcome to Dr. Meghna ma'am to begin the session on feature engineering with pandas. Without any further delay, I now hand over the session to Dr. Meghna ma'am. Over to you, ma'am.
Thank you, Ria ma'am and Grantav sir. Thank you. So without delay, we are starting our session. Okay. Just a minute. I just share my screen. Okay. Is it visible?
Yes, ma'am.
Okay, done. Thank you. Okay, yesterday we have seen two libraries. One is a NumPy and another one is a Pandas. So whatever the libraries we have learned, that we are going to use with the feature engineering concept. Okay, so now you can see that what is the use of Pandas library and NumPy library that actually useful in a machine learning. Okay, so today we are going to learn about the feature engineering. Now, when we are building a model, okay, and model should be accurate. Your model should give the accurate result. Then and then it will be useful in a real life. Otherwise, that model is not really useful. Okay, so feature engineering we can consider that is a part in that we are making our feature better. What is feature, what is engineering, that I'm going to tell you after the 5 to 10 minutes. But first, whatever the model, so here when we are learning machine learning, it is totally based on data. Okay, so whatever the model we are built, that is totally based on the data, because model is learning based on the data. So whatever the data we are giving, if that data is dirty, then model will learn the dirty things. Okay, model is not giving the accurate result. But if we are giving our data proper, accurate data, then your model will give the accurate result. Okay, so that is the main thing. And for making our data proper, accurate, for that we have to learn the feature engineering. So this is the most useful part, or we can say the most important part of your learning of a ML, machine learning. If your data is proper, then and then your model will give the proper result. If your data is not proper, then your model is not work properly. So that's why, see, already in Python, all the classes are available, libraries are available, okay, all the algorithms, like if you want to use KNN, SVM, and all the things, directly you can call that class and the methods, you can pass the data, and that will give you the result, okay. But the main thing is here data. If your data is accurate, then and then it will give the result properly, okay. Otherwise, doing applying a ML algorithm, that is the easiest task, but the main thing is the data. And for the cleaning the data, you're making a proper data, we have to learn to do the feature engineering. So that's why it is called as a, this is the most important part of your machine learning, okay. Now, so let's going with the feature engineering. Before starting the feature engineering, first understand about the life cycle of the machine learning, okay. Okay, so first, what is machine learning? Machine learning is doing what? It learn from the data and give the result. This is a simple definition, okay. So like a human being learn the things from the experience, like that machine is learning the behavior and pattern from the data. So same thing, like the human being learning the new things from the experience, same thing apply here for the machine. Then machine can learn the data, the behavior of a data, the pattern of a data. That's why, and then take the decision. So that is called the machine learning. Okay, now this is the basic life cycle of machine learning. Just we have to go through this for the 5 minutes, that how the machine learning works. Okay, so this is just a basic we can say the architecture of a machine learning or life cycle of a machine learning. Okay, so let's see here how machine learning works. Okay, so let's first, in the real world, we are collecting the data sets. Okay, so data sets may be in any form. Yesterday we have seen the data set in a form of list, dictionary, in a CSV file. Okay, so from the real life we are collecting the data set. Okay, we retrieve the data, okay, from the API, from the web scraping. Okay, so we can collect the data sets, we can retrieve the data, and that data we are passing for the data preparation stage. Okay, these are the different stages of a machine learning life cycle. So first we are gathering the data, retrieve the data, and then after we are giving that data for the preparation purpose. Okay, now what do you mean by data preparation stage? What do you mean by data preparation? Okay. Okay, let's see in data preparation, these are the 3 stages are there. Okay, that is, one is a data processing and wrangling, feature extraction and engineering, feature scaling and selection. These all are considered as a data preparation stage. Now, in data processing, we can say we can clean the data. If any data have a missing value, so we can delete the row and that columns. Okay, so that is called the data cleaning we are performing there. Okay, then if suppose missing value are there, then we can fill the data with some value, some constant value, or some using the mean and median, like that. So that is called the data processing. We are doing the data processing stage. We are cleaning the data, we are filling the data of a null value, that we can do here in the data processing. Okay, now this second stage is called the feature extraction and engineering. Okay, so that is feature extraction and engineering. It means from the existing data or from the existing features, we can create new features also. We can reduce the features also. We can add some features and manipulate the features. So feature extraction, it means you are creating the features, you are reducing the features. It means you can make your features better. Okay, so which are the main features are there that you are identifying? Suppose you have 1,000 features in your data sets, and you are giving that data to your model, and model will not perform properly, okay, because all the data are not necessary, and that data are make confused to your model. So that's why what exactly done here in feature extraction, which are the main features are there that you have to extract. So from the 1,000, only 20 features are important. So we have to identify that these are the only 20 features are important for our model, and only that 20 features you have to give to the model, okay. But for that you need a knowledge of that domain, and regarding that features, all the things are required, okay. So in feature extraction, you can create the new features from the existing features, as well as you can reduce the features, as well as you can select the main important features for the model. So that will be performed in the feature extraction and the engineering, okay. And the third stage, we can say feature scaling and selection, okay. Now what do you mean by feature scaling and selection? Guys, if you don't understand right now whatever I am saying, it's okay, we will go thoroughly and understand deeply, okay. These are all the things. Now the third one is a feature scaling and selection. Now what happened, scaling means range, okay. Like your age is in a range of a 1 to 100 or 1 to 120. Maximum the people can live up to the 120 years, okay. So that is the range of age is in a years, okay. Unit of age is a years. Suppose I am giving you a height, the height may be in a centimeter, okay. Then if we are consider weight, then weight is in a kg. So here units are different, okay. One is in a year, another one is in a centimeter, and third one is in a we can say in a kilogram, okay, kg. So these are the units are different, and as well as the range of that unit is or we can say the scale of that unit is different. For example, we can consider that year, so the year range is a 1 to 120. Centimeter we can give into the float, like for example we can give 4 centimeter to 150 centimeter, for example, okay. And we can give for example the third one is a kg. So maximum we can give the range from 10 kg to the 100 kg, okay. So here the range of each and every feature is different. Now what happened, the data which is in a different scale for the each and every features, then again the model will get confused, okay. So what we have to do in a feature scaling, the range of the each and every feature should be same. We have to convert the range of age from 1 to 120, that will be converted into the 0 and 1, as well as the kg, that range is from 10 to 200, that also we have to convert into 0 to 1 scale, 0 to 1 range, as well as the centimeter range is also we have to convert into 0 to 1 range, so that all the range, all the features range will be remain same, so that your model can understand better. Okay, so that's why these are the data pre-processing preparation, that is we can consider data pre-processing also. Okay, so before giving data to your model, you have to do the pre-processing. That means you have to clean your data, you have to extract your features, important features, you have to scale your features. These are the necessary things to work on a data. Okay, so this data, when your data is prepared properly, then you have to give to your model. Okay, so model, it's nothing but your machine learning algorithm which get the data, perform some mathematical operation, because algorithm, it's nothing but a mathematical formulation. Okay, so that you have to do here using the machine learning algorithm. Okay, one more thing I am forget to tell you in the data preparation, machine learning algorithm only understand numerical value, because algorithm, it's nothing but a mathematical formula, and mathematical formula only understand the numerical value. Okay, so whatever your categorical data, that also I am going to explain you. So whatever your categorical data, it means that is in a string, like are you your gender is there, that is a male or female, so that is considered as your categorical data. So that data also you have to convert into the numerical form, and then after giving to the model, because only model can understand, machine learning algorithm can understand only the numerical data. So this all the things you have to do into the data preparation. Okay, that is a part of a data pre-processing. That's why it is very important thing in a machine learning. Once your data is prepared properly, you have to give your data to the model or a machine learning algorithm. Okay, so that machine learning algorithm works on that data and gives some result. Okay, that you can give the result of a particular model will give the result in a form of accuracy and precision. Okay, so you can understand that your model is working properly or not. So that model evaluation you can do. Okay, if your model gives a 70% result, for example, your model gives a 70% result, and that 70% result we cannot say that is a good. If you are working with the health domain, okay, so the person life is dependent on that particular model. If someone has a not a cancer and your model is detecting a cancer, then what happened after listening that he has a cancer? Okay, so even though he has a not cancer, but he know that the model give that he has a cancer. So that is a wrong prediction is done. So 70% is not proper for the health domain. The result is not proper for the health domain. So result is not coming proper, it giving a wrong decision. Then what you have to do? Again, you can give your, again, you have to work on a data preparation. Okay, again, you have to do the cleaning of a data and feature extraction. Maybe some features you have not considered that is important. Okay, so you have to do the again the feature extraction and all the things. Again, prepare your data properly and give it to the model. Again, model will reply you that it will increase the accuracy up to 80-85%. Like that machine learning. So when it finalized, and then you can deploy your model. Okay, so this is the basic life cycle of a machine learning. Okay, again I am repeating, you are collecting the data sets. Okay, you can from the data set, different data sources are there, web scraping is there, API is there. Okay, some SQL data you have, whatever the data you have collect, that data you have to prepare and give it to the model. Why? Because data is very necessary to train the model, to learn the model. Okay, so there are different stages in the data preparations are there. One is a data processing. It means you can do the cleaning of a data, you can fill the null value. This should be done into the data processing. Feature extraction, it means whatever the necessary features are there that you have to extract. Okay, or we can create a new features also. And in feature scaling, you can make your features, they are in a different range, that way you can convert into the same scale. Okay, because if it is in a different rate, then model will get confused. So that's why you have to convert into the same scale. Okay, now, so these are the things, as well as you have to convert your data, because model, it's a one type of mathematical formula, algorithms are a mathematical formula. So you have to convert your data into the numerical format. Okay, so that is the things will be done in a data preparation, or we can say in the in one word we can say the data pre-processing. And these are the stages of pre-processing. Then we can give the data to the model. If your model give a proper result, then it can go for the deployment. If it is not giving a proper result, then you can again work on a data preparation. Okay, so this is the one life cycle of a machine learning. Okay, now we are going with the what is data pre-processing. Okay, this is the main thing. Feature engineering is also a part of a, sometimes we are calling is a data pre-processing. Okay, so these all the things are, feature engineering is a part of a data pre-processing. Okay, just a minute. Okay, now let's continue. So what is data pre-processing? Before learning data pre-processing, first we have to understand these two words, data and pre-processing. Okay, so let's first understand what do you mean by data. Okay, so in the real world, the data may be in the form of text, it may be in the form of image, it may be in the video, and it may be in the audio. Okay, so these are the data. When we are collecting this data are not clear. Okay, so these are the data. Sometimes the images we are taking, that is not a proper pixels are there, so that is called the noisy images. Okay, so data we are collecting, some missing data are there, some redundant data, duplicate data are there. So these are the things. Video is not clear, audio is not clear. Okay, so these are the different from, that is a text, image, video, and audio. Okay, and this data are not clear. Okay, so we have to convert this raw data, the original data, into some meaningful data. Okay, so that is called the pre-processing. So pre-processing, it's a nothing but a one step which convert your raw data or noisy data, dirty data into the meaningful data using some different techniques that we are going to learn. But so that is called the data pre-processing. Okay, so data pre-processing, it's a nothing but it's a process which convert your raw data into the meaningful data. Okay, it clean your data, it remove the noise from the data, so that will convert into the meaningful data using the different techniques. Okay, so that is called the data pre-processing. Again, I am repeating. First, there are two words, data and pre-processing. Data, it means your raw data. You are collecting your data from the different sources that may be in the form of text, image, video, and audio. Okay. Now, these are the data are not clear. So that data not clean. So that data you have to pre-process. Okay. So that you are giving some, apply some techniques and convert this data, raw data, into the meaningful data. That is called pre-processing. Okay, so this is called the data pre-processing. Okay, now let's go ahead. What is data pre-processing? Why is data pre-processing important? Okay, why data pre-processing is important? Data pre-processing we are doing, but why it's necessary? Okay, so data in the real world is dirty. As I earlier told you, the data in the real world is dirty, not perfect data we are getting. Okay, so just a minute. Data in the real world is dirty. Like, why, how we can say that the data is dirty? Okay, so we can say the data in the real world is dirty because it's incomplete data, it's a noisy data, it's inconsistent data, or it's a duplicate data. So if this type of data are available, then we can say is a dirty data. Incomplete data, it means when you are gathering the data from the Google form. Okay, for you are creating one Google form and spread to your class and tell to them, just kindly give the your personal information and like that. Okay, so you are collecting the data of the students, but some of the students are not writing their age, they are writing their month and date and month, but not writing the year. So that is incomplete data. Okay, some of the person have writing a 200 age, so that is a noisy data. It means that is a meaningless. The age range is 1 to 100 maximum, and you are writing a 200. So that is not a proper data. You can consider that is not in. That's why it is called the inconsistent. Okay, someone is giving we are writing about the age and someone is writing 5.4. So that is not a proper thing, or like inconsistency is there. Okay, so and as well as someone is filling 2 times data. Same data they are giving it 2 times. So that is called the duplication is there. That's why this data is called as a dirty data. Okay, so in real life, when we are collecting the data someone has incomplete, someone gave a wrong answer, so someone have a 2 times, duplication is there. So that's why data in the real world is called dirty. Okay, and that dirty data we have to clean, because the machine learning model work on a data. If you are giving a clean data, then and then it perform good result. If you are giving a dirty data, then it will give you the bad result. Okay, so Here, one thing is written, machine learning algorithm follow the rule, learn like a kids. Okay. How we all, when we are kids or even in our life, we are learning from the experience. Okay. We are learning from the experience. And if we have done a mistake, second time we are not doing that mistake again. Okay. So machine learning are working on the same rule. Like for example, here we are giving example, learn like a kids. If we are giving a good moral and values to our child, he or she can learn the good values and morals in the life. They give the respect. If we are giving the respect to someone, they can also learn that they have to also give respect to the others. So if they are learning the good things, then and then they can learn the good. But if we are saying some bad words to someone else, and the kids are watching that, they also understand the same thing, that bad words we can say to the any person. So if we are giving a bad things to the kids, kids also learn the bad things. Okay. So same like that, machine learning algorithm is also following the same rules. If we are giving a bad data to them or dirty data to them, that will give a bad result. If we are giving a clean data, proper data to the machine learning algorithm, it will give you a better result. Okay. So this is the one rule is there, GIGO, that is a garbage in, garbage out. If you are giving a garbage through the algorithm, it will give you a garbage result. If you are giving good things, then it will give you the good result. Okay. So this is the fundamental of a data pre-processing, why we need the data pre-processing. Okay. Okay. Steps, techniques in a data pre-processing. Okay, which are the major steps in we have to work with the data pre-processing. So these are the mainly 5 steps you can work with the data pre-processing. 1, data cleaning, data integration, data reduction, data transformation, and the data discretization. Okay. Again, I am repeating which are the major steps in a data pre-processing: data cleaning, data integration, data reduction, data transformation, and data discretization. Okay, let's see one by one what is the data pre-processing steps. Okay, first one is data cleaning. Okay, now, so what do you mean by data cleaning? Data cleaning means filling the missing values, smooth out noise while identifying outliers, and correct the inconsistency in the data. Okay, so ultimately data cleaning, it's nothing but if you are finding any null value, then you can fill the missing values in that. Okay, whatever the null values are there or missing values are there, you can fill with some values. Okay, so that is called the data cleaning. See here, one example is given here. That is, one table is given here which contains the country name, 2000 year, 2001 and 2002. That metric stands for capita. So this is the information it is given here in this table. Now see here, in left side, there are 3 in 3 column. The 3 values are null into the different columns. Like in United States, 2002 value is a null. In India, in 2001, there is a null value. And then Russia Federation, in 2000, there is a null value. Now, these are the null values are there. Okay, we can remove this data also. Like we can delete this row, India row, and this Russian Federation row. But that is not a proper solution, that you are deleting a row and columns from the data set. Okay, that we can learn ahead also. But there is a rule. Suppose your data size is limited and you are removing the rows, then what happened? Your data is, for example, 2000, 3000 data are there. From that, 1000 data are null, which contain the 1000 data null. Then you just reduce the size of your data. Okay, after deleting, you just get the 2000 data. So that is not a sufficient data, because in machine learning, just I am giving the example in 1000, but in machine learning, the data are in a lakhs. Okay, or more than lakhs. So then and then your machine can learn better and give the result proper. So here we can restrict, like when we can delete the data, overall 5% data are missing, then we can delete the data. But if the data are more than 5% are missing, then we have to do what? We have to fill the missing values. Okay. So instead of deleting data, you have to fill the data. Now, to fill the data, you can use the mean of the columns. You can take the mean of this all the value and fill the data. You can take a median. Okay, these are the different way. Using that, you can fill the data. Okay, so see here, after filling the data, it will look like this. Maybe they are filling the data with the mean value. So they are taking the mean of this all the data and fill the data here. Okay, so this is the one way. Second, they say smooth out noise while identifying outliers and correct the inconsistency in the data. Outlier, it means suppose one faculty member is teaching you in the class. Okay, they are teaching, so some of the students are not paying attention. Even right now I am teaching you, but you guys may be not giving the attention. Someone is playing the game, someone is chatting with someone else or talking with each other. So what I am doing, for example, what the teacher is doing, they are not paying attention to those students because that students are making a focus, they are making a noise in the class and disturbing the class. Okay, so that's why the teacher is not giving the attention to that students. So that is called the outlier. So what they are, we are not giving attention to that students, we are removing that students like that. So that is called the outlier. Those student is called the outliers, and because of that student, whole the class is disturbed and not giving a proper result, or not giving a not learning properly. So that's why that outlier we are that is called the noise, and that we are saying outliers. That student is called the outliers, and we are trying to remove that outliers. Okay, so that is also we can consider that part of a data cleaning, and we can correct the inconsistency in the data. So here inconsistency is there, so that we can do with the data cleaning. So this is the first step of a data pre-processing, data cleaning. Okay. Now, second, we can say the data integration. Okay. Now, what do you mean by data integration? Okay. So second step of a pre-processing, that is data integration. Now, what do you mean by data integration? Data integration is a technique to merge data from a multiple sources into a coherent data source such as a data warehouse. It means when we are collecting the data, we can integrate the data and make a one final data set. Okay, because when we are collecting the data may be in a SQL form, in a Oracle form, in a CSV, in a JSON format. Okay, so data we are collecting from the different source. We can collect from the API, from the web scraping. Okay, and in a different format also. Okay, so we are collecting the data from the different source, from the API, from the web scraping. Okay, like that. And the data comes into the different form also. It may be in a CSV form, it may be in a JSON form. Okay, it may be in an image form. Like that, we are collecting the data. Now, so see here at the left side, there are three different sources are there, different formats are there. One is this table, another one is this one, and another one is this one. Okay, so now what we are doing, we are integrate this all the data and make a one final data set. Okay, yeah, but when you have to remember this thing, when you are integrate the data, there is a correlation between that data set. You are collecting the data, but there is a no relation between this table and this data and this data, then you cannot combine it, you cannot integrate it. Okay, so for integrating the data, you should know about the domain knowledge of that particular data set. Okay, but for collecting the knowledge, we don't need to go for the like I want to collect the health data, so there is no need to I have to become a doctor and then after collect the data. We should collect the domain knowledge of that and then after integrate the data. But when you are integrating the data, you have to check that surety that they are correlated to each other. Okay, and then you can integrate the data, or we can say the merge the data. Okay, so see here, these are the data are correlated. That's why they have make integrated into the one data set. Country name is there, the country code is there, indicator name is there, and these are the data of a different year for the particular country. Okay, so these are correlated, so we can integrate that data, we can merge that data. Okay, so when you are integrating the data, you should check is there is a correlation or not. So data integration, you are collecting the data from the different source and in a different format. You have to first check the data are correlated, and then you can integrate the data. So this is also one part of a data pre-processing. Okay, so this is called the data integration. Now, third is what is data reduction. So this is the third step of the data pre-processing, that is a data reduction. Okay, now data reduction is a technique used to reduce the data size by aggregating, eliminating redundant features, or clustering, for instance. Okay, now for example, what do you mean by data reduction? Data reduction, it means you have 1,000 of features or 1,000 of columns are there in your data set. Okay, now all the columns are not necessary. Sometimes the columns are repeatedly redundant features are there, redundant type of data are there. Okay, so what you are doing reduce the data. Okay, that features you are eliminating from the data set. So that is called the data reduction. Okay, so you are eliminate that redundant features that maybe like date of birth is there and age is there. Okay, for example, date of birth is there and age is there. So there is no need for the both the data. Either you can use the date, so from that you can count the age also, and either you can use the age. So there is no need of a date and age, both the features. So in that case, you can remove any one feature. So that is called the data reduction. Okay, so you can eliminate the redundant features and you can make the cluster also. Sometimes you are making the same type of data are there, then you can make a cluster of that data and you can reduce the size of your data set. So that is called the data reduction. Okay, so see here, we don't need the unite country name and country code, both the things. So see here, they have make only one column, use the only country code. Okay, then this is not an exact example, but just like for example, they have reduced, they don't need the 2000 data, they need only 2001 data, they need only 2000 2002 data. So they can take here the two columns only. Okay, and this CO2 emission matrix term for capita is already known. So that column is also not, indicator name is also not necessary. So that's why they have reduced the data reduction. So instead of they are taking the 6 column, they are working on only 3 columns. So that is called the data reduction. Now, the fourth step is we can consider data transformation. Okay, what is data transformation? Okay, now this data transformation we learn in a detail, that is called the scaling concept. Okay, that is called we are learning normalization and standardization in that. So right now I am giving you data transformation. It means you can transfer your data before giving to the ML model. Okay, because ML model is working on a same scale data. Okay, so there are some techniques are used like normalization and we can say the standardization, which will convert different into the smaller range. Okay, the range are different for the each and every unit or each and every features. That range will be converted into the smaller range like the 0 and 1. I have earlier given you the example, like see here. The range of this is a 29, 2.610, 17. Okay, so normally we can see here the range of data is from 0 to 20. Okay, and like that, if someone else data is there, so the data range is from 0 to 100. Okay, now the range is different. Now ML model will get confused. The different range are there. So that's why what happened, what we are doing, we can convert a data range into this smaller range using some scaling techniques. That is, we can convert into the smaller range like 0 to 1. So here see, this are all the data are converted into the 0 to 1 range, 0 0.20, 0 0.9. So it is between the 0 to 1 range. This also range is come to the 0 to 1 range. Okay, that is called the scaling concept, and that is here it is called as a data transformation that we are going to learn practically. Okay, so data transformation, it means you can transfer your data before giving to the ML model for train the data. And for data transformation, it means that will convert your data into a single scale in a smaller scale, smaller range like 0 to 1. Okay, so for that we are applying the normalization and standardization techniques. So that we are going to learn thoroughly. Now, next is a data discretization. Okay, now what do you mean by data discretization? So data discretization technique transform numeric data by mapping value to interval or a concept labels. Okay, it means we, like for example, see here, we have a data of age 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now this data we can give and make a one, we can say the in a range like interval. Okay, so we are making a group here. One group is a 1 to 3, another group is a 4 to 6 year, and another group is a 7 to 9 year. Now when we find age, that is a 1 that we can keep into this group, 2 that is also we can keep into this group, 3 that also we can keep into the this group, and like that we can we can divide the range of the attribute into the intervals. So whatever the range is given, that we are converting to the intervals and into the group. This is called the binding of your data. You are giving your data into the groups, converting into the intervals and assigning to that. So this is called the discretization. Okay, so data discretization techniques transform numeric data by mapping value to interval or a concept labels. Okay, if we are consider the student have a, for example, student have a first class, second class, or a third class. Okay, so we can consider or distinction. Okay, so if he has a greater than 70, then it will go to the distinction. If he has a greater than 60 to between 60 to 70, then go for the first class. So like that, you can discretize your data. Okay, so that is also you can do in a pre-processing. So these are the different types: discretization technique, binding, histogram analysis, cluster analysis, decision tree analysis, and correlation analysis that will be used for the data discretization. Okay. So ultimately, it can reduce the number of values for a given continuous attribute by dividing the range of attributes into the intervals. So whatever the continuous range is there, that will be converted into the intervals. Okay. So these are the 5 steps of data pre-processing. One is a data cleaning. Second is a data integration. Third is a data reduction. Fourth is a data transformation. And the 5th is a data discretization. Okay. So in data cleaning, we are killing the data with the deletion as well as we are filling the some missing value. In data integration, we are collecting the different data sources and we correlate it and merge the data. That is called the integration. Data reduction, it means we have 1,000 of features are there, all are not necessary, then we can or some redundant data are there, then we can reduce the size of the data set using the data reduction. Then data transformation, it means the data features range is in a different that we can convert into the smaller range like a 0 to 1, that is called the data transformation. And data discretization, if your continuous value is there, that will be converted into the data interval in interval scale, that is called the data discretization. So these are the data pre-processing steps. Okay. Now let's move to, so data pre-processing, this all are considered by types of feature engineering, we can say. But what is exactly feature engineering? So one step is the data pre-processing. Second, we are, before giving the data, we have to do the feature engineering also. Okay, so what is feature engineering? Okay, so just a minute. Okay, thank you. Now, what is feature engineering? Okay, so here again there are two words is there. One is a feature, second one is a engineering. Okay, now what do you mean by feature? So feature is an attribute or property shared by all of the independent units on which analysis or prediction is to be done. Okay, so it's nothing but a one type of attribute or property that is shared by all the independent units on which analysis or prediction to be done. So feature is the main thing, because based on the features we can do the prediction. Okay, so now what do you mean by feature? So feature is nothing but an attribute, or we can say the property. If we consider there is a car, okay, so car has a different features, like we can say car color is there, okay, car shape is there, car model is there. So these are called the features. Okay, that is, we can say car colors, like and values are like white color is there, black color is there, red color is there. Okay, so feature, it's nothing but a attribute or property of a particular things. Okay, and that is remain independent. There are number of independent variables are there, features are there. Okay, and based on that prediction should be done, that feature should be analyzed, and based on that prediction is done. Okay, so first we are understand what is feature. So feature, it's nothing but attribute or property. For example, car has a different features like car color, car model, like these are considered as a features. Okay, and the features value is there, we can say the color, red, green, blue, that is called the features value. Now engineering, it means in a life there are lots of problems are there, we are trying to solve that problems using some techniques. Okay, and we can do something innovative, that is called the engineering. Normally the word engineering say in a life lots of problems are there. Okay, we can solve that problem using some techniques, and we can come with some innovative things, that is called the engineering. Okay, so based on this two word, what is feature engineering? I have written here. Feature engineering is the process to create feature. So you can create the features, extract the features from the existing features. It means from the existing features, you can create the new features also. Okay, so you can create the features from the existing features by domain knowledge to increase the performance of machine learning model. But when you are creating the new features from the existing features, you should have a domain knowledge. Then and then you can create the new features. But if you don't have a domain knowledge, you can't create the features. Okay, if I want to work on a health domain, as I earlier say, okay, so a health then I need some knowledge. I have to go through the thoroughly regarding that things and need a domain knowledge. So I have to understand each and every features. First, I have to learn what is the meaning of this feature, what is the meaning of the second features. So I have to learn the domain knowledge regarding that particular problem. Okay. Okay, so for that, there is no need to, you have to become a doctor to solve that domain knowledge, but you should know each and everything, whatever the features you have taken, that features you should know. You have to gain the knowledge regarding the features after consulting the doctor also, after meeting some members of the health, and you can collect the knowledge. Like that, you can understand the domain knowledge, then and then you can create the new features. Okay, and if you are creating a new features that is regarding your domain knowledge, you can create with the domain knowledge, then your machine learning will give a proper performance. Okay, so if you are making a new features and that is a particular new features are good, then your machine learning model will give you a good performance. Okay, so that's why you need the domain knowledge. If you have a no any domain knowledge and you are creating the features, and then after that data you will give to the machine learning model. That will not give you a proper result. Okay, so that's why feature engineering is required. Okay, why feature engineering is required? Okay, so quality data always help to improve the accuracy and performance of machine learning model. As I have told you earlier, that if your data is good, then your machine learning model give the accurate result. If your data is not proper, then your machine learning model is not giving the proper result. So that's why the same thing, machine learning algorithm follow the rule, learn like kids. As I have already told you, whatever the moral values you are giving to the kids, that they can learn. If you are giving the good things, then it will the kids can learn good value. If you are giving then teach them bad things, they will learn the bad things. Okay, so when you are working, so feature engineering, data that will be done feature engineering, you can extract the features from it and giving to the ML model. Okay, if its model is not performing proper, it will go again for the feature engineering and again give the data to the ML model up to the accuracy is not proper. Okay, so this is a part of a ML life cycle that I have shown you earlier, so I'm not going further here. Okay, now in another terms, in a simple language, what is the feature engineering? Okay, so feature engineering is the process of leveraging domain knowledge to engineer and create a new features that are not a part of the input data set. It means whatever the data are not available in your data sets, and from the existing, based on your knowledge from the existing features, you can create the new features. That is called the feature engineering. These features can greatly enhance the performance of developed ML models. So whatever, based on the domain knowledge, you are creating the new features, and that definitely enhance the performance of your model. So this is the summary of your whatever I have discussed. Feature engineering can involve the creation of a new feature from the existing data, combining the existing features, or selecting the most relevant features. So these all tasks are considered as a feature engineering. You can create the new features, you can combine the existing features, or you are selecting the most relevant features. Like 1,000 features are there, so we are not selecting all the features, we are selecting some 20 features from that which are the important for your model. Okay, so these are the tasks are done in the feature engineering. In other words, feature engineering is the process of selecting, manipulating, and transforming your raw data into the features that better represent the underlying problem and thus improve the accuracy of the machine learning. So whatever the step we have seen, that all the steps are covered here, that you can transform the data, you can select the data, you can aggregate the data, you can extract the data. This all the things are covered in the feature engineering. Okay. Now, what are the process of the feature engineering? When you are working with the, so this is a simple step that you have to, so when we are doing the feature engineering, what you have to do? First, brainstorming or testing the features. Okay, so you have to do the brainstorming for that, and you can give the features to the your model. Okay, if your model is not giving a perfect result, then decide what features to create. So first, brainstorming or testing the features that whatever the features are already available, that is work properly or not, so that you can give to the model. If your model is not giving proper result, then decide what features to create. Now based on that existing data, you have to decide which are the features are important, which features we have to create. So decide it and create the new features. Okay, now again give your data to the model. So whatever the checking, the new features are there. So how the features work with your model. Okay, if model is giving a proper result, then it's okay. If it is not giving a proper result, then improve your features if needed. Okay, so again do the brainstorming and all the things and create the features. So improve your features if needed, and again go back to the brainstorming and create the more features until the work is not done. So this is the major process of the feature engineering. Okay, now let's learn here with the example, what do you mean by feature engineering? Okay, so let's see here. We have a 2 column here. Okay, forget about this red one right now, just focus on this 2 column. train boarding time and train reach at station. Okay, train boarding time, that is a 10 a.m. and the train reach at the station, that is a 10:15 a.m. Okay, like second, for the second train, that is a boarding time is a 5 p.m. and train reach at is a 5 p.m. on an exit time. Now we have a knowledge, there is no required knowledge, this is a common sense. Okay, so that is a domain knowledge we have here. Okay, so that is a, these are the time written here, the boarding time and the reach time. But from these two features, we can create some more features also. So here, that whatever the shown in the red, that is a new features we are creating from these two existing features. For example, we are creating a new features, the delay or on time. So based on that, we can check if it is a boarding time is a 10 a.m. and the train is reached at 10:15 a.m. It means that train is a delay. So that is a new feature we have created and we assign the value to that, that is a delay. Okay, if train is on 5 p.m. and it is reached at the 5 p.m., it means the train is in on time. Okay, so that is delay or on time features we have created here. Okay, so that is a new feature we have created here. Same like that, we have created one more feature, that delay time, means how much time it will be delay. Okay, so for example, see here, the first train is delay for the 15 minutes. Okay, the second time is a 0 minute. So like that, you can create the new features from the existing features, but domain knowledge should be there. Here we have a domain knowledge regarding that, so that's why we can easily create the new features here. Okay, now examples of a feature engineering, one more example. Okay, when we have a date and time. Okay, date and time, like we have a date and time 7th April and 12 o'clock, 10 April and the 23 hour and 4 minutes is there. Okay, so we have a this value. Now from this we have a this feature. From this we can create a more features, like we can create a hour. So from this whole time we can create hours, we can create the day, so that is the date, 7th day of the April, month, that is a 4, then year, that is a 2020, and day of a week, this is the second day of the week. Okay, like then after we can create here the one more sorry, we can check with the another value, 23 hour, 8 April, sorry, day is a 8, that I have did a mistake. Then here the 4th month, April month is there. Here instead of this 10 is there. Huh? And this is a year 2020 and day of week is a 5th. So based on this data, we can create the 5 new features. Okay, if you have a domain knowledge, you can create the 5 new features. Okay, now again the one more example, feature engineering. There is a age is there and there is a one column is called the sex. So that is a person male is there or a female is there, that we can find out from this sex column or features. Okay, now so from that you can create the more features, like I can create here one column male, this is called the female. Okay, because why we have to create this column, that I will show you in the next concept, that is called the one hot encoding. Okay, in that we are creating the features like that. So and so we are creating here the, when male is present it will give you a 0, sorry 1, and then here female is not there, so here 0, male is there, then it show 1, female, so 0, male is 1, male is 1, female here present, no, so 0, female, yes, 1, male 0, female, yes, 1. Like that you can create 2 new features, male and female. Okay, because the model can, this is a categorical data. Okay, now model can understand only numerical data, so that's why you have to convert your categorical data into the numerical data like this. Okay, and you can create a new features. This is also part of feature engineering. Now what is the age range? Age range is, now we have created one more category that is called the binding discretization. That is called this features we have created, that is a age range. So here we can divide the age range like 11 to 20, 21 to 30, and 31 to 40. So now let's check this 23. So that is age range is a 21 to 30. 12, so age range is a 11 to 20. 34, so we can create 31 to 40. Like that we can do the data binding also and create a new feature. So these are called the features engineering. Okay. Now let's go ahead. Okay, when we are working with the feature engineering, or we are working with the standardization, normalization, one-hot encoding, so you should know about some data types of the variables. Okay, so that's why I'm going through just thoroughly that you should know about the variable also. Okay, so what is the variable? So variable is any characteristics, number, or quantity that can be measured or counted. In earlier days in C language and C++, we are considered that any memory location which has a name that and in that we can store the value, that is called the variable. Okay, but here in a machine learning, variable is any characteristics, okay, any number or any quantity that can be measured or counted. So the variable which is measured or which we can say is counted, like if I have shopping of purchasing 2 books, it means we can count that 2 books are there. Okay, we can measure that it is in a which kg is there, any unit is there, so we can measure it, we can scale it. Okay, so that's why it is called as a variable which has a characteristics, number, or quantity that can be considered as a variable. So the variable can be a measurable or we can say the counted. Okay, now this is the example of a variable. We can say like this is the 10 a.m., 5 p.m., 10. So these are the features. In that we are storing the values 10 a.m., 5 p.m., 10, 15 a.m. It is a delay. We can measure that it is a delay. We can measure that it is on a time. Okay, so that is example. Okay, again we can check here. So these are the same example I have given. So for male it is a value is a 1, storing value female for 0. So these are the variable we have say. Now what are the types of variable? This is the important thing. Okay, so we have to learn here the different types of variables. Okay, the main category of variables is 1 numeric variable, 2 categorical, dates and times, and mix. Now in numerical, there are 2 types. Just understand these terms. You have to understand these terms. So numerical has a 2 category. One is a discrete and the continuous. And category have again 2 category, ordinal and nominal. This thing you have to understand. What do you mean by ordinal? What do you mean by nominal? What do you mean by discrete, continuous? Okay, that you have to work. So in numerical, there are 2 types, discrete and continuous. In categorical, you have 2 types, ordinal and nominal. Okay, so let's learn about what is numerical variable. Okay, so numerical variable is a variable where the measurement or number has a numerical meaning. Okay, so whatever the value is there, that should be in a numeric and that has a numerical meaning. Okay, so see here all the features which has a numerical value. The numerical measurement is there. Okay, so here in age, that is a numerical value, weight in kg, that is a numerical, and that has a meaning. Income, that is a 59 lakh, like that. Number of vehicles, 2, 1. So that is a variable where the values are in a numerical form. Okay, with the measurement or number. The measurement, it means number of vehicle 2. Okay, what is the income? 5,000. So that is called the measurement or any number. So that is a numeric meaning, like percentage 90.83, 62, 65. So that have a meaning. Now what are the type of numerical variables? Okay, so numerical variables that hold the numeric value, they have a 2 types, discrete and continuous. Okay, now discrete variables, I am going a little bit faster because we have to cover more things, that's why. So not going faster, but a little bit faster because these things are easy, you can understand easily. What is discrete variable? Okay, so the value which can be counted as a whole value, fixed that is called the discrete variable. Okay, discrete variable, in other words, we can say the integer variable. Okay, so here we can say the value which has a whole value or a fixed value. It means the numerical value that is numerical, but it is a whole value like 145, 73. Okay, but we cannot consider here 23 point. Float value cannot be considered. Okay, 23.457, these are not considered in a discrete variable. So integer value we can consider as a discrete variable. Now what is continuous variable? The value contain range. The value which contains range measurement called as a continuous variable. It means float. So in short, the continuous variable, it is nothing but your float value. Okay, so floating value consider as a continuous. So in integer value, that is a numeric value, numeric value, there are two categories, discrete and continuous. In discrete, the values are measurable in an integer form, and the in continuous variable, that is in a float terms. Okay, now the categorical variable. Okay, so that is the third form. Sorry, categorical. Second types. Category, in that there is a ordinal and nominal. Okay, so let's continue with the categorical variable. So the value category variable are selected from a group of category, also called the labels. Okay, so like for example, you have a labels like A, B grade. So A, B, C, D, E, F, like that the labels are there. Like quality, so the quality may be poor, good, very good, excellent. These are the labels are there. So that is called the categorical variable. Okay, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, these are the labels. Products, laptop, bag, mouse, it means we can consider, like for example, we cannot say, but we can consider that string, that will be considered, which has a label, that is called the categorical variable. Okay, now Python language, Python, Java, C++, C, Go, HTML. Okay, so some label value is there, that is considered as a categorical. Now in categorical, there are two types of category variable. Okay, understand this thing, because this is necessary for the one-hot encoding. Okay, and label encoding. So this is the thing you have to learn here. So in categorical, ordinal and nominal is there. Okay, ordinal and nominal is there. So what do you mean by ordinal variable? Okay, so ordinal variables are one type of categorical variable in which the categories can be meaningful order. Okay, it's a label here. Categorical variable, it means it's a label. A, B, C, D, poor, good, very, excellent, January, February, like that. It's a label. But that label has an order, meaningful order. That's why it is called the ordinal variable. The label which has an order, that is called the ordinal variable. Okay, one more example is here is rating of a product. Okay, rating of product. It's a good product. It's a very nice product. Excellent product, for example. Okay, you can give the rating of the product. So that is also considered as an ordinal variable. Okay, which has a meaning that you can compare. Like see here, these are the grade. Okay, like A grade is a good compared to the B. B is a good compared to the C. C is more important than the D. D is more important than the E. The quality of the product, poor, it means that is not a good product. Good product is there, very good is there, excellent is there. It means excellent has a more value compared to the very good. Very good has a more value than the good. Good has a more value than the poor. So that is why it is called the ordinal variable. This has the order. Okay, January, first month, second month, third month, fourth month. So they have an order. So ordinal variable is a one type of categorical variable because it has a label, and categorical and that is a meaning, it is in a meaningful order. When the ordinal variable convert into the number, then it has a mathematical value. Okay, so this ordinal number we can convert into the number. So if we are giving A has a 5 number, B has a 4, C has a 3, D has a 2, and E has a 1. So we can give them a number in a order. So A has a 5, it means A has a great value compared to the B, greater value compared to the B, like that. In excellent, we are giving a 5 value, very good, we are giving a 4, good, we are giving a 3, and poor, we are giving a 2. So excellent has a more value compared to the very good and the good. So that we can convert into the number in a mathematical value, because machine learning can understand only the numeric value. So these are the ordinal variable. Okay, now second one is a nominal categorical variable. So nominal variable is the same like a ordinal variable, but there is nothing that indicate an in-string order of the labels and in principle. It means they are in a label format. So that is because it's a categorical variable, so they are in a label format. Okay, but this label has a no greater value and no less value. All are equal. If we are consider products, laptop is there, bag is there, mouse is there, torch is there, mobile is there, shirt is there, but we cannot say laptop has a more value than the bag, bag has a more value than the mouse, mouse has a more value than the torch. We cannot say. If we are learning a languages, Python is a more greatest value. Python is a more famous value than the Java. Java is a more famous language than the C++. We cannot here consider any comparison. Okay, they all are considered equal. So that is called the nominal variable. So it is also one categorical variable, but they have a no order. So that's why it is called as a nominal variable. So all labels are equal. All labels are equal. There is no order here. Okay. No mathematical value will be assigned. That laptop has a 1, bag have a 2, mouse has a 3. No, not like that. Okay. Now example color. So we can say color, that red, green, white, black. Each has a equal priority. Each has a equal value. So there is no red is a more great than the green value. Green is a more great value than the white. No, there is a each has a equal value. So these are the nominal and ordinal variable of a categorical variable. Okay. Next is a date and time variable. So date and time variable can contain the date only, time only, or a date and time. Okay. So these three things will be covered into the date and time variable. Now, for example, when we are collecting, when we are logging in any app or log out in app, then they can store the date and time value of a login and log out. And based on that, they are giving you some discount and like that. And they can store some, they can work out on that. So they can, which time you are logged in and what is the time of your logout. Based on that, they can show you the some products. Okay. Click on ads. So we are, how many times you are clicking on that ads. Okay, so that also, so how many times, sorry, in which time and date you are clicking on the ads, that will be stored in a date and time format. Money withdrawal, on which date and time you have withdraw the money. Okay, sister power on off, so that date time also store. Baby bond report, so in that also the date and time is there. Date report, what is the date and the time. So in that cases, we can use the date and time. So date only is there, time only is there, and based on that, you can create the new feature, that is a date and time. Okay. Now, some mixed variables are there. So mixed variable, the variables which contains the numbers and the categories labels. Numbers are there, also the category labels are there, called as a mixed variable. See here in the percentage. Okay, so the teachers has filled with the mixed variables value, like in number also, in the label also. If someone has a see here, they have written 85 percentage, 90, 40. Okay, if he has a for example, they can write for fail, they can write the failed word here, label. Okay, fail label here. For some student, they have written like the criteria is up to 90, they have written the 90, 40, 85. But if it is going above 90, they have written like this A++. So this thing which contain the mixed variables, okay, which contain the numerical as well as the label. Okay, so like that they have filled the data, so that is called the mixed variable. Okay, now when we are doing the data pre-processing, the data pre-processing contains the different methods for the missing value. Okay, that we are going through the practically also, but right now let's learn about the missing value. What is missing value? Now we are going through the this thing, so understand this thing properly. Okay, missing value is the variable or any observation. Values are not stored, called as a missing value or data. Okay, in any variable there is no any things is written. Okay, values are not there, that is called the missing value. So see here in this table, there are age is there, sex is there, male, female, and range is there. See here, there is a this value is not there, this value is not there, this value is not there, this value is not there. So this is called the missing value, the data which contain the missing value. Now how we can handle this missing value? Okay, this is a part of a data pre-processing, how we can handle this missing value. So there are the different methods are there, using that you can handle the missing value. First, ignoring the missing value rows and delete the rows. Okay, it means ignore this missing value, you can delete that rows. If the data if any row don't have a data, then you can delete that row. That fill the missing value manually, either you can go that and fill the value manually. Okay, then global constant, you can fill the data with the any global constant value, like unknown value is there, male is there, female is there, someone has not written male and female, then you can write down the unknown value, so that is called the global constant value. Okay, so that also you can use. Measure of central tendency, it means you can fill the data with the mean, median, and mode. Okay, measure of central tendency for each class, so that means that categorical variables are there, in that the class is there, so you have to take the mean of that particular class. I am showing you with the example also, but right now just I am giving the name of that. So measure of central tendency for each class and most probable value. It means you can use the ML algorithm also for filling the missing value. So these are the different way to missing the value. Let's see one by one. Ignore the missing value row and delete the row. It means if you get some, see this table, developer, it's a Java or Python, experience of that developer and the salary of that developer. Okay, now check here, these are the missing value in a salary. So now one way is that missing value row and delete the row. It means if you find the missing value, delete that row. So see, now the new table is there which contain this, remove this second row. So only 4 data are available. This row is deleted. Okay, but this is not a proper way to deal with the missing values. Okay, if you have a limited data and you are deleting the data, then your data set is remain minimum, has a minimum size. Okay, so that is not proper. You can make like this, like if 5% data are missing data, then you can delete. So there is a normally they are following the rule, if your data have only 5% data are missing, then you can delete that row. Only 5% data you can delete, not more than that. Okay, but this is not a proper way to, we can say, the deal with the missing value. So second is a fill the missing value manually. Okay, so you you can fill the manually the missing value. Okay, so how you can fill the missing value manually? Now see here, there is a percentage given here and here given the present absent of the student. Okay, if so through this data we can check that if student is remain present, then and then P is done. Okay, if percentage of student is there, present percentage is there, then it student percentage, if he get 80%, 45%, 34% and 0. Okay, so we can observe that data and check that if he got the 34%, it means that student remain present in the class, then he will get the 34%. So here manually based on the observation of data, you can keep here the P. It means that student remain P. So missing value you can fill manually. But this is also not a proper method because here there are only 4 rows. But when you are working in a real life, there are lakhs of data are there, thousands of data are there. You are not going to fill the data manually. Okay, so this is also not a proper method. Third is a global constant. Okay, now you can fill the data with the global constant. Like there are 2 rows are here missing. So now what happened? You can fill with the global constant. So whenever in age there is a numerical data are there. So in numerical data, like wherever the missing value is there, we are giving what? 0. So we can fill the data with the 0 value. Okay. So you can take any constant, and wherever you see the missing data, then you can fill with the 0. Okay. Now, second is a column is a sex. So gender is there. Okay. Now here, whenever we find the male and female, okay, and we say that this is a missing data. So what we are doing here through the global constant unknown. So there is a third value we are inserting here, that is a global constant, that is an unknown value we are missing. So whenever we get the missing value in a sex column, that features, then we can fill it with the unknown. Okay. So this is the third. This is a way global constant, but this is also not a proper way we can do for the deal with the missing value. So the one more way is there, measure of central tendency, and this way is normally used into the data feature engineering for deal with the missing value. So normally what we are doing, this is called the measure of central tendency. In that, mean, median and mode is used. Median spelling is wrong. So mean, median and mode is used. Now what happened here? Maybe everyone you know about the mean, in median and mode. Mean, it's nothing, but it will take the average of this all the value. Like for example, see here, these are the data, Java, developer, then experience and the salary. Okay, now these are the missing value. Now what happened if I want to fill the value? So what this mechanism is do, it will take the value of each and every row of a salary and then do the mean, take the average of the all the values. So when you do the summation 20,000, 25,000, that is a 45,000, then 85,000 plus 85,000, that is a 165,000, 1,65,000. Divide by 4, it will give you a 41,250. It means you have taken the average of all the value and you are filling here. Okay, so this is the thing we are filling with the average value. So whenever the missing value is there, we are filling with the average value. So one way you are taking the average of all the rows and you are keeping here in a missing value. That is the one way. Normally we are using this thing. Either you can do the median, okay, either you can do the mode. Now how to calculate the median? Maybe you know about it because these are the general term, mean, median, mode. In median, what we are doing, we are sorting this data. Like for example, we have a data 1, 2, 3, 4, 5. If it is an odd number, total 5 data are there, 1, 2, 3, 4, 5. So which is the median? Which is become a median? 3 is become a median value. So we can fill with the 3. Missing value we can fill with the 3. But it is a even data 1, 2, 3, 4, 5, 6. We have a 6 value like 1, 2, 3, 4, 5, 6. So what we are doing? The 2 value, 3 and 4. So 3 plus 4 divide by 2, the whatever the 3.5 value comes, that we can keep here. So that is the median value we are keeping here like that. These are the example I am just giving you. So take the median, sort the data, take the median of this. So here if we are sorting the data 20,000, 25, 40 and 80,000, we can take the 25,000 plus 40,000 divided by 2. So whatever the data comes, that will be keep here in a missing. So that is called the median. Third is a mode. Mode, it's nothing but mode frequency data. Which data are coming frequently? Like here, here it is not shown, but for example, 20,000 comes again and again. So mode frequency data is a 20,000, so that we can keep with the 20,000. But when it is used mean and median, when you are working with the numerical data, then you are using the mean and median. But when you are working with the categorical data, then you have to go with the mode. Okay, so remember this thing. When you are working with the mean and median, then you have to go with the when you are working with the numerical data, you have to go with the mean and median, and when you are working with the categorical data, go with the mode. So this is the one way to fill the data. Now another way is also that, again, sometimes it create a problem that it take the average and fill the data. So here one more precise way is there to measure of central tendency for each class. Okay, so mean, median, mode for each class. So now what happened, it will give a better result. For example, here we have a categorical data Java and Python. Okay, so now we are doing what? We are taking the average mean of a Java. So Java mean 20,000, 25,000. Okay, and we are taking 20, what is the value? 25 and 20. So 20 plus 25,000, that is a 45,000 divided by 2. So that is a 22,500. So that we can keep here in a Java class. Okay. Another class is a Python. Okay. We have a two value, Java and Python. So another class is a Python. Now what we are doing, whatever the data available for the Python, that we are doing. So 40,000 and 80,000, that is a 1,20,000 divided by 2. So that is the average is comes 60,000. So in Python, wherever the Python has a missing value, we are keeping with the 60,000. Okay, so this is, we are doing a mean, median, mode for each and every class and filling the missing value. Okay, so that will give you the average value of, see, Python is a 40,000, 80,000. So that is a nearer value you are getting. Java has a 20,000 and the 25,000. So you are getting the nearer value. Okay, so that will be done here. So it will give you a better result compared to the earlier techniques. And most probable value, that is, we are using the ML algorithms. Through the ML algorithms, you are keeping the missing value, fill the missing value. Okay, through the ML algorithm, you are filling the value, missing value. Okay, so some algorithms are used like linear regression, you can use decision tree, you can use and fill the missing value. So what happened, whatever the data available with us, these are the value which are the field data are available with us, we can train our algorithm with this field value, and then after we can paste the value with the this missing value, and whatever the data we get through the model, that we are filling here. Okay, so like ML algorithms are working the same like that, ML algorithm we are using to fill the missing value. So whatever the data available with us, that we are keeping into the model. The models are trained, and then after we give the test data, and whatever the value we get, that we are taking and again give it to the missing value. So this is the most probable value. So you can use the ML algorithm also for filling the missing data. Okay. Then so up to this, we have understand the part of data pre-processing and feature engineering. What is the concept of feature engineering? Okay, in data pre-processing, how to fill the missing value, that we have learned. Okay, now, okay, before going the feature scaling, let's learn some practical of filling the, because you guys may be bored because theories continue, that's why. Okay, so let's continue with some practical portion of missing value, how to fill the missing value. Okay, so let's continue. Jupyter is on. So I'm showing you some example. We show that how we can fill the data, missing data. So we are not going through all the methods, but we can go with the one or two example. Okay. Okay, let's see here. I have prepared one example for the data. We can say the data cleaning. Our data cleaning, the first method, we can delete the rows and the columns. Okay. Is it visible? Actually, we are connected with the YouTube and I am connected with the Zoom, so that's why I can't get, but maybe you will. Okay, I have shared, so definitely you get the screen. Okay, let's see with the data cleaning. Okay, so first we have yesterday learned about the NumPy and Pandas library. Okay, so that is used here. So first we have to import the whatever the libraries are necessary, that we have to import into import here in this program. So first we have to import the NumPy as NP. We have import the Pandas as PD. Now we have to I want to show you the result with some diagram, okay, and with the chart. So that's why I have import here the library, that is a matplotlib.plyplot, and we are creating a alias as a PLT. Okay, so this is a one way. Sorry, this is the we have to import the library for drawing the charts. Then import the Seaborn as SNS. So some of the charts are available in Seaborn. These both are used for the visualization, for the drawing the charts, okay, or graphs. So for that we are using these two libraries, Seaborn library and Matplotlib library. So whatever the libraries are necessary, that I have import here. Okay, now as seen yesterday, we need the data. So for reading the data, we are using, for loading the data, we are using the read CSV function of the data frame. So pd.read_CSV, this will read the CSV file. Okay, this CSV file, and that CSV file is in a row string format, so that's why I have written here R, and this CSV file data will be converted into the data frame, so that we are storing into the df variable. Okay, so df equal to pd.read_csv, we have read the data. Okay, now after reading the data, let's check. If I am writing here df, it will show me the all the data. If I want to check that how many rows and columns are there, then yesterday we have already discussed that shape attribute is there. So df.shape, which will show that there are 1460 rows are there and 81 columns are there. So remember this thing, how many rows are there? 146, because we can delete the rows which are have a missing values. That's why just remember that 1460 and 81 columns are there. Okay, now df.head 6, it will show me the first 6 rows of my data set. So this is my data set which contain the data of the house prediction. Okay, so this is sell price is a target variable and other are the independent variable, and sales is a target variable. Okay, now let's check. See here what happened. Only I can see the sum of the columns and rows. If I want to check all the rows, okay, so for that all column and rows I want to see. So for that, because there are 81 columns are there, and here it can't show the 81 column, so that's why what we have to do, we have to write, this is a one just for your understand purpose, pd dot data frame has a one more method, set_option. Okay, in that you want to see the all the maximum columns, so display dot max_columns. Okay, if you are writing here none, because it will display all. If you are writing here 2 3, so it will display like that. Okay, then like that display dot max_rows, it will display all the rows here. Okay, so if I am writing here pf dot head only, it will show me, I am writing here 6 because it will show the whole the screen, cover the whole the screen. That's why I'm writing here 6. But now you can see here all the 81 columns you can see. Earlier it will not shown 81 columns. Some of the columns are shown, and like that if I am not writing here 6, it will show you the all the how many rows are there, 1460, all the rows to me. Okay, now like that tail function we have seen, that is a shown the last 6 rows of the data frame, that we have already seen yesterday. That's why I'm going a little bit faster. df.info which show the details about your data sets. Okay, so just a minute. Details about your data sets, like how many rows are there, how many columns are there, what is the column type of that particular column. So it is id is integer 64, ms subclass is integer 64. Then null means how many data are with the fill up the value and how many null values are there. So see here, the 91 non-null values are there, other one are a null value. Okay. Like that you can see all the data. Now if I want to check this, also we have covered yesterday, that's why data pandas is a necessary for the feature engineering. So df dot is null, it means is any value is null. So we want to check that is there any null values are available. So for that we are using the null method. Now what is null method is that if value is present, then it will give you a false. If it is not present, then it will give you a true. So now see here, somewhere you can got the true value. It means these are the data are missing. Here also you can get the true value. So these data are a missing data. Okay, see, these are the true. Wherever you find the true, that each and every column contain the missing value. Okay, so this is in a, so all the rows, because we have written earlier set option for the whole max column and rows, so that's why it will show the all the data. See. Okay, so you can see up to the all the rows and column which are the missing, and but it is quite confusing that we have to check it each and every one. So we have already learned that sum function. So df dot is null. If it is a null value, then count it, sum it. How many null values are there? So this will retrieve that id has a 0 null value, ms subclass has a 0 null value, zoning is a 0 null. But yeah, lot frontage column features has a 259 null values are there. LA has a 1369 null values are there, because we have to find out the null value and we have to clean that data. So that's why we have to first find out how many null values are there in a particular column or in particular features. Okay, how many rows are there which has a null. So mass winner type has a 872 rows null value. BSMT call has a 37 null value. So these are the things we have to get after using the is null and sum value. Now let's draw the heat map. Now heat map is there, which is show the distribution of your data. Okay, and it will show that the how many null values are there. So see, we are using the matplotlib and Seaborn library for the drawing this graph. So this is the graph which contains the 25 by 25 size figure, and heat map we are drawing for the only null value. df dot is null. So here this heat map is shown. See, it is like this. So this is shown in a black and white figure is shown here. So now this is like whatever the white portion is, whatever the black portion is, that is a fill data is there. But whatever the white portion is there, that is a missing value. So see, it shows that LA has a missing value, loss frontage has a missing value, mass Venus has a missing value. So these are the missing value. So look like that we have a face, and in the face have a some acne are there. So we have not a good face. Some face has some damage on our face. So it is considered that this is your face, and your face contains some acne and the damage on your face. Some, we can say, dark dabba is there. Okay, so that is consider this frame. Now I want to clear my face. I want to remove this all the acne and dark dabba from this my face. Then what we have to do? We have to first we have to remove this values. Okay, which has a not a null value. So that we want to remove. So first or as we have already find out the how many rows are null in a particular column, that we have seen. Now what we have to do, df dot is null dot sum divide by, so we get the all the null values, how many rows that we have seen earlier. Okay, now divide by df dot shape of 0, it means total number of rows. Okay, and multiply 100, it means it will give your data in a percentage. Okay, so null value percentage, it is given into this variable. Now when we print this variable, it will show me that lot frontage have a missing value. Earlier we have seen the total number of values. Now it will give in a percentage. 17%. LA have a 93% null values are there, missing values are there. Mass winner have a 59% null value are there. BH city call have only 2%. This have only 2% value are a null value. Okay. Why we have count, this one is a 47% null value. This is have a 5%. Okay. Why we have count, this is 96, 99, 80% null values are there. Why we have count this? Because we want to check that, because all the data we cannot, like we, if this have a 99%, so that we can remove. But if it is have a 5%, then we cannot remove the rows of this features. Okay, so we have to do what? Those data we have to remove which have a greater than 20. Those column we want to remove which has a greater than 20%, or we can say the 17%. Okay, so 17, 20%, we have a one more column here which is have a 17. So let's consider for the 17. Okay, so we first find out the which have a null value greater than 7. So our data frame has a name is a null underscore where, which contain the percentage value. Now which have a greater than 17% null value, that column I need. So keys that will return the column name. So first I have find out those column which have a greater than 17% null value, that I have found and store into the drop underscore columns variable. So now these are the columns which has a greater than 70% null values. Okay, so now I have to remove this column first. Okay, I want to delete this column. So here df dot drop, and we write here columns equal to, yesterday we have seen this drop function also. Okay, so df dot drops, which we have to give the columns equal to which, this one, drop underscore column. So whatever 3, 4, 5, 7 columns are, we are dropping here, and whatever the result that we have stored here after removing the column, 7 columns which has a greater than 70% null value, that we are storing in this variable. When we write the shape of this data frame, see here 40, 60 rows, and what is the column? 74. Earlier it was a 81. Okay, it was a 81. Now we have removed total 7 columns, so that's why the 7 columns are removed. So 7 columns which has a null value greater than 70% data removed. Now check again the heat map of this data frame. After cleaning, after removing the columns, we are checking that the heat map. Now see, your face is become little bit clear. See, still some acne is there, but your face is going to clear here. Okay, so now still I want to remove this null value. Okay, columns are removed. Whatever have a 17% above null value, that columns I have removed, that features we have removed, but still some null values are there. Okay, so again we want to clean that null value. So what we are doing, we have to check which row has a null value now. Okay, which row has a null value, and whatever the null value rows are there, that we are dropping out. So there is a one function is called drop NA. Okay, that will remove all the rows. So we have a df2 dot drop underscore column dot drop NA, which will remove the rows which contain the null value. Okay, so this column, remaining column, after cleaning the data, which are the remaining column? This one, df2 drop underscore clm data frame is there, which contain the remaining column. 76 column dot drop na. Drop na function is doing what? Which delete the rows which has a null value. And after removing it, we are save into the variable in a new data frame, that is a df3 underscore drop rows. Okay, now check the new data frame df3 dot underscore drop underscore rows dot shape. It will give you what? The new shape. That how many rows are deleted? See, earlier we have a 1460 rows, that will be now 1338. So that rows are deleted which has a null value. Okay, now see the plotting heat map of your new data frame. See, your face is become a clean and pink, right? Okay, so we have removed the missing values here. We can clean our data with the missing values. We can clean our data with the missing values. We deleted the columns who have a 17% above missing value. So first we deleted the column, then after we have deleted the rows. Okay, now check that is there any null values remaining. So df3, this is our final data frame, dot is null dot sum. Check, there is no any null value, but we have to check one by one. But we can do again sum. It will give us sum of all the column and features, and it will give you a 0. Okay, so like this you can remove the data. Okay, we are not going through this because it will make you confused. So that's why up to this, like this, we can clean our data. Just I am not reading each and everything, but I want to show that this is the one plot. If you are not getting in detail, because you have to learn about this plot also, but we are checking that the normalization of our data. It means before removing the data are look like what, and after removing, is there any changes are done in our data set? Okay, so that you can check with the displot. Okay, so here we can check the displot of a one column that we have removing, that is ms subclass. So see, this is the displot of this particular column, and after removing rows, and we can check the same type of datagram graph is created. Okay, so that's why there is a no changes are done before removing and after removing. The data should be remain same type of. So that is the thing. Okay, you can see like this using the another displot of a particular, but that you will get a confused. So I am not going through it. Okay, so this is the one way you can do the data cleaning of a missing value. Okay, there is a 1143. Let's continue with the one more example. Okay, missing value we can fill with the mean and median. Okay, so let's check that we can impute or we can fill. Impute is nothing but a fill the data by mean and median. So that is the second way we have learned. So these are the same common thing. We have import the libraries, we have load the data. Okay, we can check the shape, that 1460 and 81. Okay, again now this is a set option I have done for checking all the rows and displaying all the rows and columns. Head 6, which will display the 6 column, 6 rows. Tail 6, the last 6 rows will display. Info, that we have already discussed, that it will give the data set information. Okay, so I'm not giving much time into that, instead of focusing on the main thing. Now df dot is null dot sum, that is nothing but we can check that is there any num value is there or not in our data frame. Yes, we have a null value in this lot frontage, LA column, and like that, 87 to 37. These are the null value available. Okay, now we can make, this is in a total number. Now I want to see into the percentage. Okay, because the general rule is greater than 5% or a 10% data are missing, then you can delete it. But more than it, you can't delete. This is the general rule, but that is based on your need, and based on your data, you can delete the and change the rule. Okay, but here for showing the example, I am taking the 20% and 70%. Now the whatever the missing value are there, that we are converting into the percentage. So here loss frontage as a 70% data are missing, here 93% data are missing, here 59% data are missing. Okay, so we can check that if greater than 20% data are missing, that column I want to fetch. So the keys give the greater than 20% data. So here it will show you the 6 column. Earlier we have checked with the 17%, so it will give a 7 column. Here we are checking with the 6 greater than 20, so it will give you a total 6 column are there which have a more than 20% missing value. Now we are drop the columns. Okay, so column missing value greater than 20, that we are removing. Okay, so now we have only 75% columns are there. Now df3 num df2 underscore, these are okay. Now we want to find out the column which has an integer value, because we are filling the data using the mean and median, so we can fill the data in a numerical only. Okay, so that's why we have to select the only those data which have an integer 64 and float 64 data types. Yesterday we have seen this function also, select underscore d types, okay, which include these two data types. So here it will show the only those column which has a numeric data. Okay, now see the figure. We have already removed the 6 column which have a greater than 70% missing value. Now we see only we have a data which has a row have a missing value, and that row's value we can fill with the mean and median. Now df3 underscore num is null. Okay, now we have seen the heat map. This is after removing, we are getting some null value here. Okay, that is in a row value. Now, so what we are doing here, we just find out the value frame which has a null value. So we can get the data, only those data frame, data set which has a null value. So our data phase name is a df3 underscore num numeric data. If is null, then get the all the rows. Okay, so this any function that will give x is equal to 1, it will retrieve all the rows which has a null value and again store into the df3 underscore num. So this data set which contain the null value. Okay, this is the data set which has a null value, which has a row as a null value. Okay, now let's check df3 null is null sum. So this lot frontage has a 259 rows which is a missing. This have a 81 as a missing. Okay, otherwise there is no any other column which has a missing rows. Okay, missing values in a rows. Now what we have to do here, now we have to collect the only those column which has a missing value. So here we have only 3 column, 259, that is lot frontage, math winner, this has a 8 value missing, and this is a 81. So this 3 value I can find out using this syntax. Where for where in df3 column, df3 underscore num columns, if df3 underscore num where is null dot sum. It means if it is a null value is there, we have already find out these 3 columns are there using this. Okay, that will be assigned to the variable, and one by one it will fetch the column name where it get the null value, and that will assign into the missing underscore num underscore where, and it will display the this 3 column has a missing value. Okay, now Just okay. Now see the figure. We have drawn the figure here. This is a normalized curve. Bell shape is there. This is a skew and this is, don't go into this. Okay, forget about it right now. Okay, now df3 underscore num, that is a which has a null data set. Three features are there which has a three column which has a null value, missing value. Now fill that with the mean value. So how to do that? We have to take the mean of these columns. So df3 underscore num and mean, and that fill using the fill NA method, you can fill the data of a mean. Okay, so mean value you can find out and fill into the data frame. Now check that whatever the new data frame is there any null value? No. Zero data, zero row has a null value now. Okay, so there is no any null value is remaining. Okay, and again it plot the data frame. Forget about it. Now, if you want to fill with the median value, then what you have to do? df3 underscore num dot median, okay, and fill the data with the median value. So it will take the median value of the each and every column and features and fill with the median value. Now check, is there any median value, null value is there? No, then it will retrieve the 0. Okay, let's see with this chart a little bit. I am giving you the introduction about this chart. Okay. It will not showing here because of this thing. Okay, see here, this image will show you the normalization of your data. So this is the image of before removing your data, before filling your null data. Okay, so this is the normalization curve which show the distribution of your data. Okay, so this is the first data frame. Then after we have filled with the mean value and we have plot this diagram again with the second data frame. See. So what it show, earlier we have a curve like this. Okay, original is a green one and red is a mean after filling the mean value. The curve is look like little bit change is done in your data, but it is like a similar. See here the normalized curve, bell shape is there. This is a skew curve is there, skew, but little bit change is there in a third one, but there is they are considered as a normalized after the mean value. Also you can check for the third after filling the median value. These are the warnings, so you can okay, and after this thing, three, original, mean and median. Original is red for the original data after filling the mean value into the null value, and after filling the median. So it is mean and median is like a similar data are there, normalized data are done there. So there is a no more changes are done after filling the data in a missing value. So you can use your data for the model. So this graph showing you that your data are after filling the mean and median value, is there any changes done in your data set? So that you can compare, you can check, verify with this type of graphs. Okay, but for that you have to go little bit deeply. Okay, so these are the missing value for of mean and median. Okay, now we are concluding the session. After that we are next we can learn into the next session.
Okay, thank you, Meghna ma'am, for that engaging and informative session. We will now take a lunch break and return at 1 p.m. sharp for the next session. Thank you.
Thank you, ma'am.
Thank you. Is there any query? Then you can write down into the group. Okay. Thank you.
Okay, ma'am. I am ending the meeting now.
Okay, so thank you.